Often during motion, we may want to quickly stop an axis. During testing, this might be to prevent a crash. During troubleshooting, it might be to catch a fleeting sensor or noise signal. Whatever the reason, the XGB PLC can stop any motion move using the XPM STP or XPM EMG function blocks. The XPM STP, or decelerating stop, function block allows the user to have a controlled stop based on a preset deceleration time. The XPM EMG function block is an emergency stop that stops the motion command based on the decel time for emergency stop parameter in the XGPM software. This parameter defaults to 0 milliseconds. Note that in some situations, such as a high inertial load, this type of non-decelerated stop can cause damage to the motion mechanics. Please select which stop you will use and set your decel time for emergency stop parameter carefully to ensure no unnecessary mechanical damage results. Neither of these instructions are a replacement for a hardwired emergency stop. Please refer to your risk assessment to determine the safety needs for your application. For this example, we have the XEM Motion Training project open. This file is available to download from the XGB Interactive Guide at AutomationDirect.com. It is designed to allow us to simulate a 3-axis motion control system without having to have any physical hardware attached to the CPU. We are online with the PLC, in monitor mode, and the figurative axes in our project have all been made ready and homed. We can see the axes are ready and axes are homed bits are both high. We have also already configured our axes in the XGPM software in a different help topic. Please refer to it and the product documentation for more information on axis configuration prior to attempting any motion. Let's trigger a long direct start move. Verify that motion is occurring using trend monitoring, and then trigger a decelerating stop and an emergency stop to see the difference in the system behavior for each. If we go to the project browser on the left side of the screen, maximize Axis 1 Motion Program, and double-click on Program, it will open the program in the main programming window. Our decelerating stop command is on line 25 of the code. We see that it has a decel time of 100 milliseconds. Let's change this to 5 seconds so that we will have time to see the deceleration in the trend. Because this value is a constant, not a variable, we must leave monitor mode to change it. Write this change to the PLC, and then re-enter monitor mode. Our emergency stop command is on line 35 of the code. To view the deceleration for this command, we need to open the XGPM software. We can do this from XG5000 by going to Tools, Position Control. Once XGPM is open, we can open XEM Motion Training XGPM and go online with the motion controller. If we go to the axis parameters, we can see that the decel time for emergency stop is set to 0 milliseconds. Let's go back to XG5000 and set up our direct start. We can scroll down to line 90 to see our direct start function block. We cover the direct start function block in another help topic, so please refer to it for further details. Let's set our target position to 50,000 and our speed to 1,000. This will give us a longer move that we can interrupt with the decelerating stop and emergency stop commands. Let's set up our monitoring for this move as well. We go to Monitor, Trend Monitoring, right-click on the screen and uncheck View Bit Graph and Display XY Graph, and then right-click and select Trend Setting to add our desired variable. In this case, we will add the system flag variable pos1 cur speed to the trend graph. This will allow us to see the speed of the axis and how it relates to these two stopping functions. Since we are in monitor mode, the trend is already running. Let's trigger our direct start and look back at the trend. We see that the axis accelerates up to 1,000 and then remains at constant speed. Let's go to line 25 of the code and trigger our decelerating stop. If we look back at the trend monitoring, we see the speed curve drops back to 0 over a 5-second interval as expected. Perfect. We can do the same thing for our emergency stop command. Let's go to line 90 of the code, trigger our direct start again, go back to our monitor and verify it is moving. Again, we see the speed is at a constant 1,000. We can now go to line 35 of the code and trigger our emergency stop. If we go back to trend monitoring, we see that the axis has stopped. Let's go out of monitor mode to stop the trend monitoring, and then go backwards on the trend. We see a nice hard stop when we triggered the emergency stop. Because the trend tool trends in 200 millisecond intervals, it appears to be a sharp angle downwards. In actuality, with our motion system at 0 millisecond emergency deceleration, we would have seen the axis jerk to a stop immediately. Let's also take a look at the axis view in the XGPM software. If we go into monitor mode, we see that the axis is faulted, and the message window tells us that an emergency stop was executed. Perfect! We stopped very quickly and will not be able to restart unless we execute an axis reset. This is the perfect behavior for the emergency stop in our example. Again, please use this instruction very carefully. Extreme deceleration may cause permanent damage to a mechanical system. You will need to evaluate the motion, loads, and inertia in your system before using this instruction or configuring the decel time for emergency stop parameter. As we see here, it is easy to stop motion with the XGB PLC. We can use the decelerating stop for normal motion profiles, or execute a much faster emergency stop that will also fault our axis, preventing immediate restart. Regardless of what our application requires, one of these two stop function blocks can do the job.